Hi everyone, so we are doing the structure of ATP synthase. For that, you need to understand that it has two domains. One is F0 domain and one is F1 domain. F1 domain is extramembranous domain. That means it lies outside the membrane. This is your inner mitochondrial membrane. So in the inner mitochondrial membrane, you'll have the F0 domain, right? Or FO domain, right? So this is one thing. And the F1 domain, it is mostly in the mitochondrial matrix, or you can say it's extramembranous because it's definitely not in the membrane. So this is one thing that you need to understand. So it has two domains. I hope that's clear. And its location is in a mitochondrial membrane as a whole if you talk about the ATP synthase. If O is embedded in the membrane, and if you talk about F1, it projects into the mitochondrial matrix. It's also known as extramembranous domain. Then, when you talk about FO domain, which is inner mitochondrial membrane domain, let's look at its components. So first of all, this functions as a proton channel. It has an alpha subunit right here. You can see this acts like a proton channel. So this is basically the major proton channel. That's the alpha subunit of the FO domain. Then you'll have beta subunit. This beta subunit, it acts like a stator. What is a stator? It's something that anchors. So it provides an anchor and it anchors the F1 domain. So you can see F0 domain is trying to anchor the F1 domain and keeping it intact. So this is done by the beta subunits. When you talk about C subunits, you have C rings. There, so it forms an entire C ring that rotates with the proton flow. So as the protons come, this also as the protons are flowing, so these C subunits will keep on rotating. So FO is in the inner mitochondrial membrane. It contains the proton channel. This is its main function. I hope that's clear. So proton movement it causes the rotation through FO um, C rings. I hope that's clear. Now F1 domain it has alpha 3 and beta 3 hexamer. So alpha 3 and beta 3 hexamer. Now beta subunits are catalytic. These are catalytic subunits that you need to understand. Then gamma subunits they have a central shaft. Gamma subunits have a central shaft that rotates. Now you have another domain as well, which is subunit as well, which is delta and epsilon subunit. So there are two more. So again, you have A3, alpha 3 and beta 3. So this is basically hexamer. Hexamer is something that comprises of 6 units. So you have alpha 3, beta 3 hexamer units, where beta units are catalytic. Then you have the gamma subunit, which is the central shaft that basically holds the FO domain and F1 domain together, but it is basically the part of F1 domain. This is the shaft, right? So this helps with the rotation. Then you have epsilon and sigma. These are basically stabilizers. They stabilize the entire complex. Epsilon and sigma, sorry. So F1 in the mitochondrial matrix contains the catalytic activity. So its function is it contains the catalytic activity. So I hope that's clear. Now, once again, you can just have a look and just have it stored in your memory.